So to find then the area between two curves, we're going to take the integral from a to b, f of x minus g of x dx. And remember the way we defined it, that f of x is the upper curve and g of x is the lower curve, right? Just like you see over here, upper minus lower. All right? Okay. So, you know, sometimes you get confused, one function versus another function, you know, when you have like different scenarios and situations. So just remember, it's always a to b, upper minus lower dx. That's it, upper minus lower dx. Let's use that because later on when we're going to turn this on its side and it's going to be left to right versus top down. So, you know, let's get the terminology down from now. Okay, so finally our first one, we need to find the area of the region between y equals negative x squared plus 6. That's this one in the red, right? So y equals negative x, oh no, sorry, it's not, I'm so sorry, the blue one. Y equals negative x squared plus 6 and the line y equals x, right? So it's the area between these two, so basically that one. From x equals negative 3 to x equals 2. So look at this one. You have the two curves here. Where do they meet? One intersection is here at x equals negative 3. One intersection is here at x equals 2, right? So if I'm scanning this from left to right, I start from x equals negative 3 and I go to x equals positive 2. In this problem, you're given the bounds. Sometimes you won't be given the bounds, but are you able to find the point where the two functions intersect? You can find it on the calculator. For a function like this, can you find it manually? Yes. What would you do? You just set them equal to each other and you solve for x. Yay. Okay. All right. So now what we're going to do is the area is going to be the integral from the leftmost point of intersection to the rightmost point of intersection. So from negative 3 to 2 of the upper minus the lower. And what's the upper? Negative x squared plus 6 minus the lower dx. We're lucky because the lower function is just y equals x, but if it's another function, make sure you put the parentheses because there's like, you know, distributing involved and blah, 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 blah. Okay? All right, let's quickly do this by hand. This is negative 3 to 2. This is negative x squared, negative x plus 6 dx. I just switched the order.
Why is it negative x?
It was negative x squared from the beginning. So that's negative x cubed over 3 minus x squared over 2 plus 6x from negative 3 to 2. And then you put in the 2, and then you put in the negative 3, and you get 20.833. Yay. Okay.
Do we do unit squared?
No. Okay. Find the area of the region enclosed by the parabola 2 minus x squared and the line y equals negative x. Okay. Can we graph 2 minus x squared? Okay, this is a parabola that faces down. Y-intercept is 2. Now, how do we find where it crosses the x-axis? Set it equal to 0. 2 minus x squared is 0. 2 equals x squared. X is plus or minus root 2. How much is root 2? Is it greater than 1, greater than 2? Where is it? Between 0 and 1, 1 and 2? Between 1 and 2, okay? So between 1 and 2, that's, you know, right there. So this is going to look like this. On that part of it, I don't need NASA precision, but, you know, it should go up to 2. And now y equals negative x. I know exactly how that looks. like that. Okay, now I need to know the 2 points where these things intersect, right? So what you're going to do is first find the limits of integration by setting the two functions equal to each other. And I've already set you up here. All right? So 0 equals x squared minus x plus 2. Minus 2. So 0 is equal to x plus 1, x minus 2. So x is negative 1 and positive 2. Here and here. Do I care about the y value? No. Now that I've done that, a is equal to negative 1 to 2, upper minus lower. So what's upper? 2 minus x squared minus lower, which is negative x. You see where the parenthesis is helpful? You just look, and between these two, like this and this region,
Between the regions.
yeah, always over the interval, dx. Okay? And we're going to plug this in the calculator. And we just plugged it in the calculator, plugging, enter 4.5. Okay? You're allowed to, and you know, based on, because there's like so much. This is going to get a lot more involved.
So you're thinking for the quiz we'll have a calculator.
So, you know, we learned how to find intersections. All right, so now we have two graphs. Oh my, y equals cosine of x and y equals x squared minus 1. This is the region. All right, so look, this is the upper one. I'm going to call it 1. This is the lower one in this region. I'm going to call it 2. Which one is the cosine and which one is the x squared minus 1? Cosine, is cosine number 1 or number 2?
1.
Number 1, okay? You need to know that. You need to know that. Whether or not you have the calculator with you, you need to know that. Because you know what? This might be on a non-calculator part, and I'll say, just set up the integral, but you don't have to solve it. Right? Or it would be something that you would be able to solve. So you should know. So how do you know? I start with, you know, x squared minus 1. This is a parabola that has a positive value of a, so it faces up. You know, it's going to look like that. Oh, that must be this one here. Okay? So y equals x squared minus 1. And you know what? Even like go in and write it. That must mean that this is 2 cosine x. And it's got an amplitude of 2.
And it starts
at the top. Right? Exactly. And I know that if it's a cosine at x equals 0, it must start at its maximum value. And there it is. Okay? Awesome. Okay. Now, okay, so this one, we need to find the points of intersection here and here. For this one, it's points of intersection using the calculator. Okay? Okay, so when I have a trig function, I like to do zoom 7, which is the trig zoom. What it does is that x-axis, instead of going like 0, 1, 2, 3, 4, it goes like 0, pi over 2, pi, you know, pi, 3 pi over 2, and so on. So I'm gonna select 7, and it's gonna look like this. And so let's see, right? We don't need all of this. Basically, this is what we're looking at. And let's find the point of intersection. So second calc, my graph right now, it doesn't have to be like super pretty. All I need, is for it to be practical. So I need 5 for intersect, and then you just have to, okay, so it asks you, is this the first curve? So because it wants to know which two functions does it need to find the intersection of. Is this the first curve? Yes, it is. So press enter. Is this the second curve? Yes, it is. Now, before pressing enter, though, decide which point you want to find first. I want to find the left point first. So, sorry, this is the second curve. So I press the left arrow button and just take it closer to that point so it knows where to look. Because if you put it right in the middle, it might get confused like which side to look in. So press enter. You want me to guess? Sure. There it is, the intersection. Okay? Yeah. So the intersection here is negative 1.265. Okay? Huh? That's what I got. Right? Okay, now look at what we're going to do. There is a button here, right? Right above the on button, that's STO. It's the store button. Okay? You know what we're going to do? We're going to store that value of x as a. So do alpha a. It's right underneath it. Enter. Oh. Okay. All right, so here, all right, for the last time, I'm going to find the point of intersection. First curve, second curve, guess, sure. That's the point of intersection, correct? Now, what you're going to do is this. Second quit. Go to the home screen. Second mode. Now, here's what you're going to do. You're going to store the value for x as a. So you're going to say x store as a. So store is that button right above the on. And then do a alpha, enter. That's your a. Okay? Now let's go back. Second calc, we're going to do it again now. Second calc, 5. Yep. Now go closer to the second point. Is this the first curve? Second calc. Now I want to go ahead and find the point of intersection for the second point. It's positive 1.26.
And we store that.
No. You will see.
No, didn't you know that it was obviously?
But you need to do it because you're going to store it in the calculator. Okay, shh. Now, go back and do x store as b now. Enter. Now what you're going to do, here, we're going to integrate from negative 1.265 to positive 1.265. Yeah. Now, you need to write the functions. The upper function, which is 2 cosine x, comes first, minus the lower function, x squared minus 1 dx. No, hang on, give me a second, okay? Listen up. Hang on. You must have this step correctly placed. All right? And now, okay, so here's what I want you guys to do. take your calculators and just put them face down on your desk for a minute. Okay? Now, this is one way to do it. Another way to do it is, do you recognize that there is a lot of symmetry in this problem? Yeah? If I split this down the middle, the left and right are the same, correct?
Yeah.
So if I just go from 0 to here and multiply by 2, do I get the same answer?
Yeah.
I do. So, or you could go from 0 to 1.265 to cosine x minus x squared minus 1 dx, but put a 2 out front. Okay? Either or. Obviously not in any other combination. Now we're going to go back to the calculator and we're going to do math 9. Okay? Here, we're going to go from A to B. Right? Because when we round to 1.265, we're making a huge error because now we're going to take that and put it in the integrated form of this. So we're going to put it in the sign, and then the x cubed, and then the x. And you know, when you round and you're cubing things and you're taking the sign of things, you're going to be further and further away from the precise answer. And then here we're going to put in 2 cosine x close parentheses minus in another set of parentheses x squared minus 1 dx. A comma B. Always A comma B. A comma B. No, same thing. So you put in the function in the older versions. You put all this in, comma x, comma A, comma B, enter. Yes. 4.995.